Okay, working with properties. There's lots of properties on this page. I'm going to shorten them down so that you have like a little chart. Make sure this ends up on a note card if it isn't going in there right now. So the first ones are the associative properties. I'm going to put all of these kind of together. So the first one is the associative Okay, so first of all, your chart needs titles, I guess. So first title is going to be property, because this is the associative property. And then your next one is going to be for addition. And then multiplication. Okay, I'm just going to give you, ooh, that was a terrible one. I'm going to give you an example of each if it applies. And most of the ones that apply to addition apply to multiplication as well. So, all right. So the associative property for addition will look like this. I'm going to give you a general rule, and I'm going to give you like a real numbered kind of a deal. Okay. So the first one is the general rule. It says a number plus another number in parentheses plus a third number will give you a number plus another number, and that third number, though, this time those are in parentheses. So the associative property will just move your parentheses. So think parenthesis when you think associative. Okay. Now the reason that this is useful, the associative property is useful, because it could make your life easier. It'll make your life easier if this happened to be your problem. Let's go 5 plus 3 in parentheses plus 7. And then over here, you'll see that I'll shift the parentheses. I'm going to move the parentheses from 5 plus 3 to 3 plus 7 because I know 3 plus 7. And it's way easier than adding 8 and 7 at the end. I'll get the same answer, so it doesn't really matter if you use it, if you're comfortable with your addition skills. But I know that 3 plus 7 is 10. 10 plus 5 is 15. Those are easy things to add up. So if you are dealing with larger numbers, like 45 or something large, okay, then you may want to use this property to group things that are easier to add. Okay, so there's your associative property for addition. Now for multiplication, it's going to be similar. It's going to hold the same thing, just different places. So basically this says if A is multiplied by B in parentheses and then multiplied by C at the end, that will be the same as being A being multiplied by B and C in parentheses, like that. So what that allows you to do is if you have like a bigger number being multiplied by a smaller number, maybe you see 12 times 3 in parentheses multiplied by 4. Now the reason it might be easier to multiply by 12 at the end is because I know 3 times 4 is 12. And I know 12 times 12 is 144. So it might be easier to group 3 and 4 together instead of 12 and 3 because 12 times 3 is 36 and 36 times 4 is, I'm not sure, well I do know now, but 36 times 4 is a lot harder to do than 12 times 12 because I know 12 times 12. It's part of my memorization that I did way back when. Okay? That's why that one's helpful. Alright, next property is the commutative property. The two M's, U, and then tative. Commutative. So the commutative property for addition basically will just move things. Commute. Think commute. Okay? It's not a word we hear a whole lot around here, but in big cities, when you live in a rural area or a suburb, basically, you will commute to work in the big city. So the commute is your distance that you would travel from wherever you live to wherever you work. Okay, so I commute to work from across the street. It's not that big of a deal. You guys that live in Portales, you commute to school. You go from Portales to here. We just don't hear the word very often. So if we have this, A plus B, that's the same as B plus A. It just allows you to move things around. Now this is normally only useful in the event that you have 3 things being added or subtracted. subtracted. So let me show you where that would come in handy. I'm going to put 3 things in here. So in this case, I'm going to put pretty much the same example as below, but I'm going to put them in a different order. Sorry, don't copy that down yet. I want to put 3 plus 5 plus 7. Okay. The reason that the commutative property is useful is because I can take this 3 and switch it with that 5, or I can take that 7 and switch it with that 5, because that will put my 3 and 7 together, and it allows me to go 3 plus 7 is 10, 10 plus 5 is 15. It just makes my life a little bit easier. And the same way with multiplication. A multiplied by B is the same as B multiplied by A. So you don't really see this one a whole lot unless, again, you see 3 numbers being multiplied by each other. That would make more sense to multiply in a different order. So let's say 3 times... Yeah, that's what I was thinking. Let's go 3 times 12 times 4. Okay, I might want to reorder those so that it goes, I'm going to switch the 4 and the 12, so it goes 3 times 4 times 12. I'm going to get the same answer. It's still going to be 144, but it's a lot easier to multiply 12 times 12, right? Any questions about that? Okay, these are the 2 big ones that people normally get backwards. So remember, commutative is moving things, associative is parentheses, grouping things. The association, grouping. All right. Moving on down, we have the identities, and then we have inverses. So let's talk about identity first. Identity. So the identity for addition is going to be 0. The identity for multiplication is going to be 1, because any number multiplied by that number will get itself in return. So identity is 0 for addition. So 0 plus A or A plus 0, it doesn't really matter, right? I can put them in any order, but I'm going to end up getting exactly what I started with, A at the end, right? So anything plus 0 is itself. A quick example would be 25 plus 0 equals 25. No big deal on that. Same thing for multiplication. 1 multiplied by A or A multiplied by 1 is going to give you just A. Okay? So if I had 3,752 multiplied by 1, it's still going to give me 3,752. Okay? If I take Cambry and I multiply her by 1, she's still going to be Cambry. Alright. Those are the identities. Let's talk about inverses. Alright, and I want you to put a little definition right here. Inverses, they always produce identities. Okay, now I'll make more sense of this here in a second. So a number, when dealing with addition, added to its inverse, which would be the opposite for addition, will give you its identity. Okay? So for example, the inverse of 7 is negative 7. And when I add those 2 together, I get the identity. Okay, so inverses produce identities. So if I ask you what is the inverse of negative 2, you would tell me 2, positive 2. What is the inverse of 105? Negative 105. Good. So there's no real confusion there. Good. Just take its opposite. Alright, now, for multiplication, it is a little more complicated, but you still produce the identity. You're trying to make a 1. So if I had A, the inverse of A is its reciprocal. Okay, so A multiplied by its reciprocal is 1 over A, will give you A over A, which is just 1, which is the identity. So let me make more sense of this by giving you, I'm going to give you 2 examples to leave space for them. If I had 4 its multiplicative inverse is 1/4, because that would be its reciprocal. When I multiply 4 by 1/4, I get 4 over 4, and 4 over 4 is 1. Okay. The reason I'm giving you two examples this time is because I want to give you one that looks like a fraction. So on 3/4, let's call it negative 3/4. I need to produce the identity. So I'm going to multiply it by its reciprocal, which is negative 4/3. And if I multiplied this straight across, I would get a positive 12 over 12, which is indeed 1. Okay? Give you a second to get caught up if you are behind. And then we're moving on to distribution, just to remind you, and we're done.
This will be the last.
Yes. Does anybody still need more time? Okay. You've all seen the distributed property in some manner or another, so I'm just going to show it to you one more time in a general form, and then obviously in a numbered form. Okay, so A multiplied by the addition of B and C will give you a distribution. So I'm going to distribute A multiplied by B, and then A multiplied by C. And that would be my answer. So I'm going to give you a number here where this might be a little more useful. You know, I just kind of did this the other day, so hopefully it isn't much new. Oh, I forgot to give you the subtraction one. So, if I had a number like I'm going to purchase, let's say I'm going to purchase 4 CDs. Okay? If I had 4 CDs that I was going to purchase, and each CD, was an old school one that I'm buying here, was $1.99. Okay? If each of these were $1.99, I would round to 2. But to make this equivalent, I would have to subtract my penny each time, right? So it'd be 0.01 because it was $1.99. No tax. Tax-free weekend. Ooh. Okay? So now I'm going to distribute. When I distribute, I get 8 on the first term, and on the second term, I get 0.04. So now all I got to do is take 8, subtract 0.04, which is $7.96, right? And that's how much I would have to pay for those CDs. Okay. So distributive property helps you with rounding. Is really all it does. If I bought 100 of them, I would end up subtracting $1, and I'd pay 99 bucks. Okay. All right. Continue, guys. Remember what reciprocal means. Okay. Reciprocal is just flip. So you're going to see that word in your homework. So reciprocal literally means just flip it. Remember, all regular numbers are always over 1. Okay, all regular numbers are normally over 1. So when you flip them, just put the 1 on top, and you'll be good. All right, now there's some more properties. These are all ones that you should have seen before. These are the ones that you kind of should have known. So here's another property list. Now these, yeah, you will.
We will?
Yeah, right now. So the first one is a reflexive property. And I'm just going to do the name of it in an example. Okay, so reflexive is whatever equals itself. I know this seems silly right now. It'll make more sense later on. So, as a number example, 5 equals 5. Duh. Oh, at the end of all these properties, I'm going to put POE. Know what it stands for. It's property of equality. POE. Reflexive PO. Property of equality. I just don't want to spell out property of equality 12 times. And I don't expect you to want to do that either. But as long as you know what it means, when I ask you, you're absolutely fine with putting POE. Next one is symmetric. SYMMETRIC. Property of equality. Okay, symmetric property of equality just says if A equals B, then B also equals A. So now, that might sound a little silly, but let me give you a real number. If b equals 5, if you read it the other way, it's still the same, okay? So it doesn't matter if the variable's on the left or on the right, it still means the same thing, okay?
What was that called? Oh,
Symmetric. I'm just pulling them off that chart in your book, so. Next one's transitive. Now this one takes a little bit of an explanation, so if you don't understand it, let's make sure we ask questions. And I'll explain it to the best of my ability, but sometimes if you understand it differently, we just need to approach it a different way. So this one says, A equals B, B equals C, then we must know that A equals C. Okay? Here's my real example. And it's fairly obvious, but if A is equivalent to 5, and 5 is also equivalent to C, then we must know that A is the same as C. Here, let me explain this to the best of my ability using Wesley, Tice, and Emmett. If I give Wesley 5 candy bars, okay? I give them to him discreetly, okay? And I gave Tice the same amount of candy bars, and Tice knows that Emmett has the same amount of candy bars that he does. How many candy bars does Emmett have? How much is that? 5.
5.
Because Wesley started with 5, right?
Oh, it's
and
5.
Tice has the same amount as him, and Emmett has the same amount as Tice. So it just runs down the line, okay? Alright. There are several more properties of equality that go on here. But the only one that I really want to address right now, without actually just telling you, is the substitution. So substitution. Substitution property of equality says if A is equal to B, then
Which?
I can use B anywhere in the place of
The
A.
addition property?
Substitution. Then, so I'm going to find a better way to word this, maybe not. Then B can substitute for any A. Okay, so I'm going to put B and A in some quotations just so you know they're just letters from the original problem. Okay. I should say any A in the expression. So for my real example here, I'm just going to give an equation. I'm going to say y equals 3x plus 4. Okay? And I'm going to tell you what x equals. X equals 5. So I can take this x and I can plug it in anywhere, right? You all should know how to do that part. So I would plug it in anywhere that x is. So y equals 3 multiplied by 5, right? So I'm going to put 3 times 5 right there, plus 4. 3 times 5 is 15. 15 plus 4 is 19. Heard somebody say it pretty quiet. Okay, so you're just subbing, is all it is. 3 times 5 is 15, and 15 plus 4 is 19. Okay, so substitution, that's all it is. Substitution, property of equality, crud. I didn't put PO either. Did not leave room for it. Okay, the rest of these properties that are listed on this page, the addition property of equality, the subtraction property of equality, the multiplication property of equality, and the division property of equality, anytime you hear any of those four, I want you to be thinking what I do to one side, I must do to the other side. Just like we did yesterday, where I told you what you do to one side, you must do to the other. That is all the property of equalities are trying to get across on addition, subtraction, multiplication, and division. So we're just going to do some examples involving those. So go on down. We're going to solve a problem, and then we're going to provide a justification for each step. So here we go. Here's the problem. Just split your page into two columns. We're going to have the statement column and a reasons column. So under reasons, that'll be our justification. So I'll just put backslash justification. All right. So each statement will be followed by a reason or justification. So to start with, we're given the problem 1/2 multiplied by, in parentheses, 4 plus x, close parentheses, equals -3. We're going to solve this. So, the first reason, well, that was given to us, so I'm just going to write it down. That's given. I don't need to do anything special there. It was given to us. Okay? Pretty much every step of every, we'll call this a proof, of every proof is a given statement. Okay? Pretty much the first step is always going to be a given. Alright, so we're moving down the line here. I need to get rid of these parentheses, right? But since this is an x and I can't add x to 4, the only way to get rid of those parentheses is to do what with my 1/2? How do I get rid of a 1/2 multiplied by that stuff right there?
Multiply it by 2, or multiply it by 4.
I would multiply the half by 4, but what else? I have to also multiply it by the x. What property is that? The distributive. We use the distributive property here. 1/2 multiplied by 4 is 2. 1/2 multiplied by x is, well, we don't know. 1/2 x, right? I see people get stumped on this all the time because they see a fraction and they freak out. You literally don't have to do any math here. You just have to know that 1/2 is being multiplied by x and write it down. Don't let those scare you. Let them scare you at the end when you actually have to do the math with them. Okay, and then nothing happened to the -3, so I just wrote it down. Alright, I need to get x by itself. So remember I told you you need to do order of operations backwards. So I need to look for addition and subtraction. I need to get rid of, I need to get all of my regular numbers on one side and all my variables on the other. So I want my variables, my variable term is this one. I want it to stay right there. So I need to subtract 2 to both sides. So I'm subtracting from both sides. This is the subtraction property of equality. Because I do something to both sides, it falls into the category of property of equality. Okay, so those canceled. And I got a -5 over here. And since I haven't done anything yet with my 1/2 x, I just copy it down. Again, no math on the 1/2. All I did was rewrite it.
Well, you're supposed to divide it, Thomas.
Ah, yes, sir. Okay, now Tice tells me I need to divide because it's 1/2 multiplied, right? So I have to divide by 1/2 here and divide by 1/2 here. What I do to one side, I must do to the other side, right? Okay, so to get from subtraction property of equality to the next step, we had to simplify that. Sorry, I forgot to write down that step, simplify. And then Tice just told me that I needed to divide, so that's the division property of equality. Alright, so what do we know about dividing fractions? You have to multiply and flip them. You have to multiply by their reciprocal, right? So I can't divide fractions. First rule of dividing fractions is you can't do it. So I have to multiply by its reciprocal, which is 2 over 1, which is just 2, right? So x will be equal to what? -10. And I did that by simplifying -5 multiplied by 2. And that's my answer right there. Bang.
Can you go to all the
this next piece, go ahead and flip the page if you have not already done it. This next piece, I just want to show you how to check this one real quick. Okay, so this is the checking part. If you don't already know how to do it, it's literally substitution. Okay, so I'm going to check this by taking my answer and plugging it back into the original question, or original equation. So I got 1/2 multiplied by 4 plus, I'm going to plug this in, I'm going to substitute it in, -10 equals -3. And I'm just going to verify that. So this is the substitution part. Okay. I'm not going to provide justification for the rest of this. I'm just going to show you how to quickly check it so that you know what you're doing. -10 and 4 make a -6, right? And -6 multiplied by 1/2 make a -3. Does -3 equal -3? Of course it does, every single time. So, it is correct. It checks. Cool? Any questions about it? Cool. Alright, flip page if you have not already. I told you. Alright, Carolina. Carolina was given this equation. Write it down as I say it aloud. 36 equals 5x plus 3y minus 7x. Now that 3y and minus 7x are in parentheses. We need to combine like terms here, right? Are the parentheses doing anything to this problem? Not really. Because it's addition, right? It's addition in between them. And addition is commutative and associative. So it really doesn't matter that much. So, for the sake of clarification, I'm just going to erase these parentheses so that you can see it. Okay? Now, I need to identify like terms. Like terms are the things with the same last name. That's what you'll hear me say a lot. Same last name. Okay, so I want you to first circle the x's. So there's a 5x and a -7x. Notice that I circled that operator with it. Okay, the negative and the minus look exactly the same because they are the same. Okay. Next, I have a 36, which has no other thing like it, and I have a 3y, which has no other thing like it. Okay, so all I did was circle and square and underline everything that went together, okay? So anything with the same last name, I circle, square, they're underlined with the same shape. So anything that goes together that has the same shape, I just put them together. 5 minus 7 is what? -2. The last names stay the same. Okay? And if anything doesn't have a match, for example, my square doesn't have a match, I'm just going to drag it down. Didn't do anything with it because I couldn't do anything with it. Okay? So, I'd look at that again. I say, is there anything else I can do with this? Can I combine anything? Well, no, I can't. Okay? Now I'm going to go back to the problem. And I'm going to finish this problem by answering it with what they wanted. It says, she was asked to write this in slope-intercept form. Does anybody remember what slope-intercept form? Yes and no. It's not the complete answer. It's part of it. So slope-intercept form, slope is what Tice just said. It is rise over run. But in slope-intercept form, it is m, right? So slope-intercept form is y equals mx plus b. Now the reason this is called slope-intercept form is because m is slope and b is the y-intercept. So that's why it's called slope-intercept form. It's naming itself by its parts. So in order to make this slope-intercept form, I isolate the y. Okay? I need you to isolate the y when I ask for slope-intercept form. So here we go. I got to get this guy by itself. So I need to get rid of this. How do I get rid of a -2x? I move it to the other side to make it positive. So I add 2x to both sides, right? So that one's gone. I get 2x plus 36. Again, this is no math right here. I'm literally just writing down what I have. I get a lot of people that are confused here. So please be sure that you know that these don't have the same last name. You cannot combine them. So you just write them down. Now, if you wrote 36 plus 2x, I'm not going to count you wrong. I just like the variable up front. Because Addition is commutative. I can move them wherever I want. All right, now I didn't do anything with 3y. I need to get y by itself. How do I get rid of a 3 multiplied by y? How do I get rid of multiplication? Division, so I must divide. What I do to one side, I must do to the other. What am I dividing by? 3. If I move the y, then it doesn't do me any good. I got to get rid of just the 3, right? I need to keep my y right there. So I'm going to divide by 3. I got rid of that 3 right there. Now I'm left with y equaling, well, 2 divided by 3. We don't need a decimal here. I'm going to leave it as 2 over 3. X. What's 36 divided by 3? 12. Consider this division bar much like distribution. I have to give this 3 to here and to the 36. And that's actually my final answer right there. So in reality, I had 2 steps. Add 2x, divide by 3. Cool? Questions, comments, concerns? Yeah, I'm going to do one more example like that because I feel like we struggled a little bit. Here we go. We got 3x plus 5y equals 12. And I'm going to put this in y equals mx plus b. I'm going to put it in slope-intercept form. So I need to isolate this term, my y term. How am I going to get rid of 3x? How do I get rid of a positive 3x? Subtract it. Okay, so now all I have is 5y on my left. I have 12 minus 3x on my right. Because I can't do anything with things that don't have the same last name. Now, how do I get rid of a multiplied by 5? I divide it. Right? So I have to divide by 5 on both sides. Y then will equal 12 divided by 5, which is, anybody? I don't know either. I'm going to leave it as 12 divided by 5. Minus 3 divided by 5x, right? I only leave the x with the one that had x in the first place. So I'll just leave it like that.
Yeah, 12 is 12 divided by 5.
Be 2.4 if you wanted it as a decimal. I leave it as a fraction because I know I'm going to leave this one as a fraction. So if I turn one to a decimal, I must turn the other one to a decimal, and I don't want to do it. So, there you go. All right. Now, on this problem, they gave us, okay, so rewrite the problem, 3x plus 5y equals 12. They gave us another part of this problem, and it was y equals 2 minus x. I can use the substitution property to solve this, okay? So we're ignoring this piece right here. I'm just going to zoom in on that little corner, okay? I can use substitution to solve this. They gave me 2 equations. So since y equals 2 minus x, I'm going to literally take this and plug it in for everywhere I can see the y. I'm going to take it and put it right there, okay? So 3x didn't change, plus 5. Now I'm just going to open my parentheses up and put 2 minus x right there where y is. It's going to equal 12. Okay, and I'm going to start to solve this. Now that I just have one variable, I can solve this problem. So, let's go ahead and do it. Distribute out this 5, I get 10. Distribute out the 5 to the next one, I get minus 5x. Anybody confused as to why that's a minus 5x? Yeah. I distributed this 5 times x, right? So I write down my 5x. The operator here is negative, or minus. So I go ahead and write it down. Just carry it down. Good. Now I can combine like terms. I see that I have a 3x and I have a negative 5x. I see that I have a 10 and a 12. So I'm going to combine these two because they're on the same side already. So I have 3 minus 5, which is negative 2x, right? Now how am I going to be able to combine this one with something on the other side? I got to subtract it. So I subtract 10 to both sides, subtract 10 to both sides, and I'm left with 2 on that side. How am I going to get x by itself now? Divide by a negative 2, good. And x then would equal negative 1. Now x is easy to find. Y is easier. I'm going to take my negative 1, plug it right in here for x. And then I just say, what is 2 minus a negative 1? So I'm going to write it down. Minus a negative 1. What's wrong with this negative here? Same sign, sum. So y is 3. Okay, so after I get my answers, they're coordinates, guys, they're coordinates. So I want you to see your answers in coordinate form. It's -1, comma, 3, just like that. And that's how your answer should look. All right, guys.